Let's move on to talk a little bit about edge networking. This is a topic that is near and dear to our hearts here at Field Day because we have an Edge Field Day event that we've done this year. We actually have another one that'll be coming up later this year. Techfieldday.com for more details. And of course, Stephen Foskett, has kind of pioneered this, and he talks a lot about edge computing and those kinds of things. But I don't do compute; I do networking. And so I want to talk a little bit about edge networking. Kind of what is it? What's the advantage of doing these kinds of things? Because it's an access point, right? That's the edge of the network. After that, I don't care because they're clients on the other side. It's that easy, right? We're done. We're not done. I feel like maybe we oversimplified that a little bit. What is the value of doing a lot of this kind of stuff on the edge of the network? Because I remember thinking all the way back to my classes with that traditional three-tier network architecture, you don't do a whole lot of stuff in the access layer. You do it all in the distribution layer, in the middle of the network. And then you don't do anything in the core because the core needs to be as fast as possible. So is there value in moving it down and doing things along the edge?
I think in some ways this ties in nicely with the Sonic use case, because when you're talking about disaggregated networking, edge is a use case where it makes a lot of sense, because it's not your traditional campus, it's not your traditional data center. You're going to want someone who can roll up to you with a software-defined infrastructure to support all of those various devices out wherever they are, often in strange locations like cell towers or some factory or an oil rig or whatever, or a car. So this is the opportunity to break the traditional vendor's hold on the network with new ideas and new capabilities.
I mean, a lot of companies that have kind of focused on the edge right now, especially in the cell tower base stations and on those remote locations, are trying to do that. I mean, I remember talking to edge networking companies a few years ago, and they were extolling the virtues of these container things. And look at the conversation we just had about using containerization to kind of beat that back. But I mean, does anybody have a lot of experience in deploying these edge solutions, or are we still kind of early stages of maybe I don't know if this is going to take off or not?
So I can't speak to some of the edge solutions as much, but what I can speak to is working in the facilities that run these edge solutions, supposedly. And my experience with these facilities is that they're incredibly limited in a lot of things, mainly in power. And I still get incredibly suspicious whenever I hear about edge computing, because a lot of it's like AI and GPU workloads and all this cool stuff that I'm just going like, that's a lot of kilowatts. And meanwhile, like a lot of these facilities where you're wanting to run your edge computing, like at a tower site or whatever, you might have 5 kilowatts for the site or 10 kilowatts for the entire site. Like, I don't know how you're cramming all that power in there. So I've always been a little skeptical of it from that standpoint. And so I think what that means is when you have an edge computing solution, you're going to have to be very careful about what you run on it, because I think that those workloads are going to be way more expensive than something running way off in Ashburn or, the Utah data center where it's just like, free to run them basically because of how cheap power is. And I think power is like that main currency of all this stuff that I really kind of wonder if it works. But I think, like I said, you'll be able to have some stuff, but I don't think you're going to be able to run everything, and you're going to have to be really picky about what you run there.
Yeah, I would agree with that. Although I do think like the work that like Vapor.io is doing with Crown Castle is really interesting, and like how they're thinking about how to distribute workload and maybe make use of like, unused site facilities that are within small geography footprints that aren't in the classic data center space, that are closer geographically to where a workload would need to run. Something like, in farming communities or more rural communities that have workloads for telemetry that takes too long to get back to a centralized cloud provider, but can certainly be run at edge. And so maybe they're making use of, low power ARM resources that are collected within that site facility. I see a use case there that could work. And maybe that's the real question is, does that compete with like maybe some of the, like if you're trying to do things with like, farming, rural farming or data gathering or telemetry data about what you can do for all of that, does that actually compete with like what Caterpillar or what John Deere can actually put in the equipment? Like, I think that's more of a tension model of like what makes the most sense in terms of where you put your compute workload and what sizing and capabilities are there. And do they provide something that supersedes what that capability is for that. And maybe rural manufacturing can fit in the same area.
Carl?
Yeah, I think this is a really interesting part of the conversation. Right now, a lot of the technology shift has really been to centralize this all back to data centers or back to clouds. And, I think for good reason. The problem is, when I start to look at survivability, so I work in the healthcare software space. And when I start to look at this, it's, hey, how do I make sure that regardless of whether I have network or compute, or cloud connectivity, how do I still make sure that I can still deliver care, or enable my customers to deliver care to patients? And, but we really aren't architecting things for this, right? So this distributed architecture, being able to really allow things to run at the edge, to still be self-contained and self-sufficient. Like, we're not really designing software and application stacks to really be able to do that. It's got to come back and it's got to be processed centrally and then distributed back out. So I think until we start to see more of kind of some of these applications start to enable that local processing where you can still get value from it without being able to go back to the mothership, I don't see quite as big of a drive for vendors to innovate in that space.
And I think too, in other areas, when you look at it, because I'm currently in the legal space, but I came from the healthcare space for about 8 years. One thing is, no matter what you're looking at that, I mean, it's not looking at it from a negative way, but it's looking at it from a realistic one and a practical one, right? Security, because you have such a large volume of data coming in. How the hell do you what's the word, monetize? Like, how do you narrow that down to from a proactive standpoint? You can't.
Yeah.
Right. I mean, yeah, you're going to have the costs and overhead, and you're going to need insanely more expensive hardware to run that and to keep moving edge compute, which is great. And I think that is awesome. I think it's, again, a circumstantial, but from the security piece, how do you stop that? How do you, when you have that kind of data and you're ingesting it, where's the,
because I think it was Chris's point and Ed's point, like, we only have so much power at the edge to be able to do these things, right? So what we can keep in scope for being able to make those local decisions, it's fairly small, and we're not going to scale that out.
But eventually we hit a point where the bandwidth becomes saturated, right? And that's one of the things that we've been talking about a lot recently is, autonomous vehicles is a perfectly good example. Those things dump massive amounts of data every second they're in operation. And no system can keep up with that real-time processing, which is why they're working so hard to do as much on-node processing as they can and send telemetry or aggregated statistics back and things like that. Should we be optimizing our edge networks to do that? Should we be optimizing to say, I'm going to assume you're going to use as much of your budget power-wise, compute-wise as possible on the system, rather than just saying, oh yeah, we'll put a Wi-Fi 6E uplink in this thing and just send it all back to the cloud. We don't care, because I can tell you that when an Airbus A380 lands, it has not been sending flight telemetry the whole time. They dump the drives off of that machine every time it hits the ground, because there's no way that they could send those gigs of telemetry in flight. So should we be trying to push our networks to be able to carry this, or should we be pushing back on the providers to say, you need to do more work to utilize the network that we have available?
Yeah, I definitely do think that it's a bit of a, I don't know exactly what the right term is, but it does seem like doing this stuff locally is the best solution, especially for really high stakes stuff. Unfortunately, it seems like regardless of how high stakes some of this automation and especially around driving is, like, there doesn't seem to be a lot of regulation and to it being done, I think, in the best way possible. And so because of that, the answer is, let's just do what we've done in every single field in IT forever, which is push it on the network, let the network do it, which is what everybody has always done. And so I think we have to engineer for that at some point. And that's why there's going to just be overall a blend of approaches. There's going to have to be fast access. There's going to have to be some edge compute, but it's going to be expensive. And then basically it's what's going to end up winning out is whatever's the cheapest and, or gets pushed via regulation.
I work.
Yeah, in my mind, latency sensitive workloads. Sorry, Fazal, you want to go?
Yeah, actually I can talk from my service provider experience, because we're a 5G operator. and we are exploring the edge compute use cases. We have identified some edge compute cases related to running the digital DU and CU for the front haul of the base stations, and also some offloading some user plane at the edge compute. And what we are exploring is basically we are looking for a networking solution which is very compact, which can save us power because our edge data centers are very, very small, smart, close to the base stations. So we have found out some vendors which can really offer us like a data center in the box, very compact, and it can run 100G interfaces in a 4U to 5U chassis. So it's very compact and very smart, very power saving, and we can run it, in the edge data centers. That's where we are actually exploring very compact solutions, for the edge data center. So this is our experience, and we have a plan for that.
Go ahead, Jay, if you had something you wanted to add there.
Yeah, I was just going to say that I think bandwidth intensive applications are one facet where edge computing has a bottleneck, so to speak. But there's entire markets built around latency sensitive applications, right? Like high frequency trading. How crazy those folks get with running new fiber routes, doing sort of free space optics. So I don't want to rule out edge computing just yet, but at the same time, reading about what the carriers do in terms of 5G deployments and all the headaches that they get, right? Like my backyard is New York City. Needing to deploy digital distributed antenna systems for 5G, it's a nightmare. It's a headache, right? Think about all the commercial buildings, all the landlords you have to deal with, all the space and power constraints. So it's got headaches all around.
And so to me, again, it seems like the answer is you're going to have to be very cautious about what you put on this. You're going to have to ration that out because it's going to be a limited resource and it's going to be scarce. And I think, like, again, on the topic of power, like, it's usually way cheaper to spend your power on DSP to get faster optics and faster backhaul than it is to spend your power on computing things locally, just because DSP is typically happening in an ASIC, right? Which is going to be more power efficient than general purpose compute. But yeah, like Jay mentioned, there's going to be low latency stuff that it doesn't matter how much bandwidth you have. It has to happen in this many milliseconds or nanoseconds or whatever, unit of time. And so those are the things that are probably going to get pushed out. Whereas I'm not going to be running my Oracle ERP on edge compute, right? This like Java application that eats, gigs and gigs of memory. Like that's just not going to be the kind of thing you're going to want to run on this. It's going to be very precision engineered things, and probably even like a lot of like serverless kind of stuff, like AWS Lambda style things where you're just running a code function on demand that just gets spun up, goes away, very efficient and small.
And part of that comes from the fact that we are slowly but surely increasing the power efficiency, but also the compute processing power of these smaller machines. I mean, look at what ARM has been able to do in the past few years. I mean, ARM CPUs run inside of GPUs. They've effectively become offload engines. And as they become more and more optimized for this kind of stuff, they give us more flexibility to do those kinds of things. So like we talk a lot about what we can do at the edge to kind of crunch those numbers and spend less time sending that stuff back somewhere. I mean, is the other flip side of that, because every network stream has to have a terminal point, is it, that we're reducing cloud costs by doing crunching at the edge and only transporting the aggregation? Are we saving on having to buy that monster AWS instance to crunch that data stream or those 10,000 data streams that we're sending it?
Yeah, but can you afford to build out, however many endpoints you need to be able to do that? I mean, it's one thing, if I've got this, especially with AI, or if I've got this big GPU cloud, to be able to do my processing, obviously distributed makes sense, except for if the minimum size to be able to do something is, 100 nodes, I'm not going to be able to distribute that and put all of that, compute out everywhere that it's needed.
Someone also has to manage that too, configure it, manage it, monitor it, and all that. So that's also adds cost to that too.
Yeah, and there's definitely been a lot of new players. I know at Edge Field Day, there's been several new vendors out there who are addressing especially the management aspect of the distributed edge. But again, it's it's really just trying to find where does this make sense. I worked in the in the cruise industry for a while, and we had this exact problem. I've got limited amount of space and power on the ship. I've got a limited amount of network bandwidth to be able to do things. So the core systems, obviously, they have to run on ship. I've got to make sure that people can get into their cabin. But when I'm looking at the analytics side of things, as soon as I get into port and plug in, I'm going to upload that stuff and process that back in the cloud.
We've talked a lot about applications that are running this stuff, but there's actually another thing that we need to consider, and that's the services running on the device itself that we can provide. We actually got into a really great discussion about whether or not you should run services locally or in the cloud during Mobility Field Day. Go check it out. Sam Clemens has some opinions about this, but I'm thinking along the lines of things like SASE or SSE, where all of those things were originally designed to live in the cloud, whether it's a CASB or a web gateway or anything like that. But now we've talked to companies like Fortinet who have said, no, we have the power, we can run it locally. We don't have to shell all that out. Sure, we'll push the configurations down so that they can kind of operate with a generalized policy list that we've sent it. But this isn't a question now of, oh, cloud good, local bad. It's, in due deference to Fortinet, they've spent a lot of years developing ASICs to do this stuff as fast as possible. So they actually have a hardware advantage. Is it a situation where the power of these devices is reaching the point where we can run those services? We can provide that local traffic inspection type of thing and not have to burden ourselves with having these giant cloud instances? Everybody's like, yeah, it's really cool. As long as it runs in an 802.3 AT power budget. If you want to talk about power budgets for devices at the edge, try running all of that on an access point that's only powered by 60 watts. Anyone else? Any ideas, suggestions? Anyone that hasn't spoken up yet that wants to jump in?
Everything must run on a Raspberry Pi.
The funny thing is that a lot of the value that we're starting to see in those edge computing things are the folks who have been like, I'm going to make it run on the most ridiculous restrictions that I can and use those lessons to build back to a good steady state. I think a lot more programmers would do well to remember that there was this time in the dark times long ago when 640K was more than enough memory.
I was just about to say I need to go walk over to John Osmond, borrow his grumpy pants, put them on, and then talk about how developers needed to actually be more conscious about how you can't just waste, cycle so much. I mean, gosh, I work in pretty abstract programming languages myself, but the sheer waste of cycles, because they're cheap and available, that you can do with modern abstractions and programming languages and ORMs and you name it, right? There are so many layers of abstraction that the sheer cost from a kilowatt standpoint of those is really ridiculous. And so where I think a lot of the innovation here might run is being able to have FPGAs and ASICs at the edge too. I am working on a project that's FPGA based, and it's amazing to me how it's such a different world versus the projects I work on that are in React with JavaScript and stuff. And I think that, being able to support some of those workloads that happen way closer to the hardware are going to be really important, like Rust serverless functions. If that's a thing, that'd be kind of cool. I'd love to see that.
Chris, let me throw a little curveball at you. Would you use an FPGA that has a very specialized programming language and a very specialized skill set, or would you use some kind of an ARM instance that can run P4?
Yeah, it's an interesting question because FPGAs actually aren't that power efficient because you have so many gates laid out in such a way that it's actually not that power efficient. It uses a lot of juice for relatively low throughput, but it is really reconfigurable. But yeah, I mean, I currently run P4 on FPGAs, so that's maybe an interesting
heresy
thing that I know. Yeah. I do think that you're right that ARM is probably the great equalizer here because I don't know, just from a consumer technology standpoint, the Apple's M silicon that's all ARM based. My lord, it runs Intel better than Intel. I had the i9 MacBook Pro, the top of the end one that they had, and then I replaced that with an M2 one, and I ran the same exact stuff that doesn't have ARM binaries, and it's all running x86 on ARM, and it's still more efficient. So like, I think that there's a lot to be said about the power gains of ARM, and maybe that is something I should probably think about. Is that, you know, if you were to put this Mac, which maybe runs off like, I think like 50 something watts or something like that, out at one of these facilities, it's not a supercomputer, but it's a supercomputer. Like, you know, like you can run a lot on that. And so maybe I am a bit outdated with my views on power consumption because I'm coming from an Intel and an x86 world. I think if you're on ARM, the gains are real.
Just wait. Debian is now, they have RISC-V compiled software. So they're going to be even more power efficient. Any final thoughts from anybody on the topic of edge networking? I feel like we talked a lot about compute. I don't necessarily know we talked a lot about networking, but I think maybe the ultimate kind of I don't know, indictment of this is the fact that it's more on the people that are writing the applications that run on the nodes, not on us, because was it Chris? I think he kind of said something near and dear to my heart. You know, well, let's just throw it over the fence to the networking team and let them worry about it. And I've been saying for years, I'm tired of solving your problems in my network.
Well, is it time to throw things back at the programmers and say, you need to put all the things that are latency sensitive out on the edge compute side, and everything else you have to be able to deal with centrally?
Programmers are like cats. You don't get to tell them what to do.
Oh, you do, but they don't listen.
They're just like
That's okay.
cats.